Hello, welcome to my presentation. I'm Wu at the University of Tennessee. The title of my presentation is Fine Resolution Mapping of Wetland Inundation Dynamics in the Prairie Pothole region of the United States. The slides for my presentation can be accessed by scanning the QR code at the lower left corner or visiting the URL at the bottom, gshub.org/AGU. Here is the outline of our presentation. First, I will introduce the Prairie Pothole region. Then I will show you some of the existing wetland datasets in this region. Then I will discuss research challenge and how we can use Google Earth Engine to address this challenge. Lastly, I'm going to show you some additional Google Earth Engine resources. On the right here is a Landsat time-lapse animation since 1984, so for every year annually. And you can create something like this using Google Earth Engine. You can visit the web app here, click the link to create animation like this for any location around the globe. You only need to change some parameters, then you'll be able to create like this without having to write any line of code. You can also click the notebook to look at the source code behind the scene. So first, I would like to introduce the wetlands in the Prairie Pothole region, our study area. And PPR is a vast area, covers 5 states, and there are millions of wetlands in this region. So the median size of wetlands is only 1,600 square meter, roughly 2 Landsat pixels. And most of these wetlands are relatively shallow, less than 1 meter in depth. If we follow zoom in, this is what it looks like in high resolution area imagery. And the water supplies of these wetlands come from a variety of sources, including rainfall, snow melt, and also upland inflow. These wetlands are very important because they support a variety of vegetation and animal species, and it's very important that we map these wetlands, find out where they are located and how they are changing. Okay, so first let's talk about some of the existing wetland datasets in this region. So the first one is the National Wetlands Inventory, or NWI. NWI is considered the most spatially and categorically detailed wetland inventory for the US. On the right here shows you an example of an NWI overlaid on the NAIP imagery. So 1 meter resolution. As you can see in here, the NWI is a polygon dataset. It has a variety of attributes. But there's a limitation because NWI dataset was developed mostly in the 1980s by manual interpretation and digitization of single date area imagery, and it's not up to date. As you can see from here, this polygon, the boundary no longer match the current status of those wetlands. It's very detailed polygon dataset, but outdated. The other dataset is the Global Surface Water Products developed by Google and European Commission Joint Research Center, and also United Nations. And you can see from here, this one is based on Landsat data 30 meter resolution from 1984 up to 2018, a monthly dataset. So it has a much higher temporal frequency, but the limitation is that the resolution is 30 meters. So you can see from the example here, right? You can see along the wetland edges, you can see the zigzag, and also because the limitation of the resolution, some of the small wetlands were not captured in this dataset. So what's the challenge? Wetlands are very important, and in order to manage these wetlands, we need contemporary information about their location, the extent, inundation dynamics, and why they are changing. So we have these 2 datasets. The NWI is very detailed polygon dataset, but it relies on a manual interpretation. So, and it has not been updated for many years. We also have Landsat data, the JS Global Surface Water, but they want the limited spatial resolution also miss some of these small wetlands. And as I mentioned earlier, the median size is only 2 Landsat pixels. So most of the wetlands were not captured in that data set. So how can we utilize the fine resolution NAIP imagery to map small wetlands at large geographic scale? So what is Google Earth Engine? Google Earth Engine is a cloud computing platform by Google, and it's free for research, education, and non-profit. You can sign up on the website using a Gmail account. We published a paper in remote sensing environment last year using Google Earth Engine and also LiDAR data, multi-temporal area images to map wetland inundation dynamics in the Prairie Pothole region. Here shows you an example of those inundation dynamics shown by the NAIP imagery 1 meter resolution. As you can see from here, 2009, right? This is already a dry period, so those wetlands were separated. But as time goes on, you can see in 2014 it was a wet period, and some of those wetlands were actually connected together to form a larger wetland complex. The inundation is very dynamic. And also you can see from here, one of the very challenging part is how to automatically map those inundation area. If you see from this imagery in here, the color actually are very different, right? So some like black, dark color, some a little bit green color, and also some of the texture because wave and others or sediment. You can also see there's variety of texture here in this surface water. So how can we use cloud computing, Google's engine, to efficiently map this inundation area is a very important topic. And so we, besides the NAIP imagery, we also use LiDAR data, because in this region, most of the wetlands are depressional wetlands. So if we can find the depression, then most likely we can find those wetlands. And so we selected 26 hot tank watersheds in this region. And so you can see the LiDAR data is over 100 gigabyte. We also have 6 time periods of NAIP imagery. So those are the two primary data set we use to delineate inundation area. And then once we get the result, we compare to the national wetlands inventory and also the global surface water products. At the bottom here shows you a chart, the inundation dynamic based on the 30-meter Landsat data. So you can see here some of the pixels were detected in water, for example, 90 or 100% of time during the past 35 years. But some of those are actually only detected as water 30% or 40%. So you can see the dynamic changes in here. That means the water in here, in this region, is not, most of those are not permanent. They can be temporary water or some seasonal waters. And how can we use this data set to actually do the automatic mapping? Here is the algorithm we use. It's actually very simple and straightforward. So we delineate the inundation by watershed, and so we use the original NAIP imagery, but we also add 2 additional normalized difference indices, NDWI and NDVI. Then we perform unsupervised classification. Once you unsupervise, you get some unlabeled clusters, and then we use some existing water mask to identify which clusters belong to water. And then so those are actually the potential water bodies. Once you have this, we can use LiDAR or surface depression to remove those commission errors. So basically some water bodies might be misclassified because of for example, tree shadows or terrain or others. And once we use this to refine the results, then we can compare the result with national wetlands inventory and also JRC water products. So here shows you some quick results. On the left side is the inundation polygon overlaid on NAIP imagery 1 meter resolution. So the yellow brown outline here, this is what we delineated from this imagery. And you can see here it aligns very well with the inundation area we can see from the NAIP imagery. On the right here shows you the water occurrence products. Earlier I showed you that we have 6 time periods, right? So if the value is 6, that means in those 6 time periods, that pixel was detected as water 6 times. And if it is 1, that means only detected is 1. So we can see the dynamics basically changing from maybe seasonal or temporary water to more permanent water. And especially in the center of those relatively deeper wetlands or surface water bodies, you can see those are relatively more permanent. But along the boundary of those wetlands is more dynamic, so you can see the changes gradually from the edges to the center. So this gives you a quick result, like showing you how the landscape is changing. But it also provides you a quick way that you can potentially use the result to update national wetlands inventory. Compare our results to the JRC 30-meter resolution and also the NWI. You can see the improvement dramatically. So the like I mentioned earlier, the JRC 30-meter, some of the smaller wetlands were not captured, and the NWI was very detailed, but it does not reflect the current inundation status. So we can use Google Earth Engine to quickly provide an updated status of the wetlands in the region. I also developed an Earth Engine app, so you can actually go to the URL in here to explore, and you just need to zoom in and zoom out, and then click the mouse on the map to select a water set, and then everything else is automatic. You can also look at the source code if you're interested in the source code behind. So since we developed this JavaScript-based interactive app, and the idea is that we want to apply to scale up, basically apply the algorithm to a larger area, but there's a limitation in the JavaScript-based app. You just need to do that one by one. So it's very difficult. You can apply the algorithm to a larger area. So that's why I switched to Python. So then we applied a similar methodology, improved it, and then we can automate the process to delineate inundation area for the entire Prairie Pothole region. So you can check out here using the URL, and here you can scan the QR code, and also here shows you, for example, once you click a water set and then you click submit, you will be able to compute and show you the result. You can also download the results to your local computer. So here shows you a demo what it looks like for the app. And so all you need to do is click the link and then go to the web app. After that, you can zoom in and zoom out and pan to a certain location. And after that, you can click submit. Then it will automatically delineate all the intermediate results to show you. Here shows you for example, the unsupervised X-means clusters, and also compare this one to the JRC 30-meter resolution dataset. So you can see the improvement based on the 1 meter resolution NAIP imagery with the JRC 30-meter. You can also get the statistical results plotting here on the map, and then you can also zoom in and zoom out to interact with the graph. You can also download the statistical result to your computer. So all you need to do is to click. Once you're done with one, you can move ahead to go ahead to move your mouse to another watershed. You can repeat the same process. And if you use Python, we can actually automate the process to delineate inundation area for the entire region. So this gives you a way that we can do batch processing. This is something that you cannot do using JavaScript API. So I want you to keep that in mind. And so this app was developed based on the GMap package. So the GMap package is an open source package for interactive mapping with Google Earth Engine, and I believe that it's the one that I developed during the past few months. It's open source. You can check the package on GitHub. So you can run this package on Jupyter or Google Colab. And I also developed a website that with a comprehensive documentation for the package. You can check out the link gmap.org, and you can also, for example, look at some of the tutorial and how to get started. One nice thing about this website is that you can look at the source code behind every function. So if you're interested in learning more about those functions behind the scene, you can go to the website and then click on any function, and then from there you can look at the source code. I also developed a series of tutorials and posted on YouTube. So far, I have more than 40 tutorials with a total length of more than 10 hours. And you're welcome to check out the tutorial to learn more about the package. So I also show some of the ways that how you can convert a Google Earth Engine Python notebook to a standalone website, so that you can publish a interactive web app, and then so they can share the link with anyone with internet access. So they don't have to know how to do coding, they don't have to know Earth Engine, but they're able to visualize your result interactively. So highly recommend that you check out. Okay, so that's all for my presentation. Thank you very much for your attention. I will be happy to take any questions.